Hello engineers, welcome to another video on low level design. In this video we'll look at the decorator pattern, which is another structural pattern. I hope you're ready. Let's get started. So let's first start with the intent. So this is the intent behind the decorator pattern. Attach additional responsibilities to an object dynamically. Decorators provide a flexible alternative to subclassing for extending functionality. So the two things that we need to note here are responsibilities dynamically. So it means that we don't want to attach responsibilities at a class level. We don't want to attach responsibilities at an object level, but we want to do it dynamically. We need to have control over adding responsibilities to an object dynamically at runtime. So these may be optional responsibilities, right? Some objects may need it, some objects may not need it. So if we enforce it at a class level, it may become too static, but we want to use it at a dynamic level at runtime. So that is when we can use the decorator pattern. So let's see some example use cases. The first example is a spell checker. So let's say we have an editor and you must be using some editor like Google Doc or Microsoft Word, right? Or even on our mobile phones, we have keyboard with spell checkers now. So the keyboard itself or the editor itself is a raw component, but the spell checker feature is added dynamically. It can be switched on, it can be switched off and so on, right? So that is one example. And second example is compression. When you want to transmit something over a network, you may want to compress it in order to use less network bandwidth and improve performance. So compression is an optional thing and you may want to use it dynamically. That's when also you can use compression. And you may also want to encrypt it as an optional responsibility. So in that case as well, we can use a decorator pattern. And another good example is taxes. So if you have ordered anything from Swiggy or Zomato, you must be seeing the base amount followed by the handling charge, the packing charge, the service tax, the GST and so on, right? So these things can be added on dynamically based on the restaurant needs or the Zomato needs. And these are something that are figured out at runtime. So in these cases as well, we can directly use the decorator pattern, right? Now let's see how the decorator pattern is implemented. So we can now go to the UML diagrams. So inside our structural folder, we now have a decorator pattern. And let's see how the pattern is implemented. So this is the class diagram structure of the decorator pattern. First, we have a common interface with some operations, and this is implemented by component A, component B, and so on. They all have the common operation and which they will be implementing on their own. So let's say this is a text editor interface and this is the Google Doc component which is implementing the operation. Okay. Now let's say we want to add a spell checker. So how will we add that as a decorator? First, we define a decorator interface which will also implement the component interface and it will also carry the component in itself through a constructor, right? If you observe this closely, there is a protected variable inside this decorator interface which is having the component, right? And this is passed on via the constructor of this decorator. And then within this operation, we can call upon the components operation and do any further processing that this decorator needs to do and then follow along. For example, if we want to build a spell checker as a decorator, so we implement the decorator interface and we do our operation here. And because we have the component object already available, we can do our spell checking and then call upon the main operation from the document editor, right? That way we have dynamically added some functionality to the object of component A, right? And similarly, we can have multiple decorators like this. So that is the advantage of declaring a decorator as an interface rather than a class itself, right? So quick recap, what did we do? First, we have a common interface, which is being implemented by many components, right? And then we have the decorator interface, which is also implementing the component interface and which is also carrying the component in itself. So this is a composition relationship, right? And there can be multiple decorators which will implement this interface and each of them will call upon the components operation, this operation within itself. How will it do that? It already has access to it because it is passed down through the constructor, right? So simple implementation. Let's see the sequence. So client is calling upon component A. So component A is first created. This is the base product, right? Let's say this is a raw code editor without any spell checkers or any grammar checkers. Now we want to add a grammar checker at runtime. So we will call upon decorator A and pass along this instance. So we are passing the object here, right? And this will do some decoration to it and return a decorated instance. And we can pass this decorated instance to another decorator and we get AB decorated. So the same object is passed multiple times to get more and more functionality. For example, in the Zomato example, we had the base amount here, and then we wanted to add convenience charges. So we'll call upon the convenience charge decorator, and it will return the total price for both of them. And then we call upon GST. This will return the whole price including GST, right? That way we can dynamically add any responsibilities to our object. Okay. So to understand this in code, let's take a simple fun example. Let's say we are making a coffee, right? And as you know, there can be so many variations of making coffee. So let's take a simple example. Let's say we have a coffee interface and this is being implemented by Simple Coffee. And there are two things here, get cost and get description. So let's say if we made a Simple Coffee object, we would get $5 as a cost with the description saying Simple Coffee. Now I want to provide multiple options to my customers. They can either add milk, they can either add whipped cream, or they can add caramel and so on, right? So these are optional responsibilities. So how do we do that? I declare them as decorators. And whenever a customer wants a milk, we will pass upon the Simple Coffee to the milk decorator. And in the get cost method, we will call upon the Simple Coffee's get cost and add some more money for adding the milk. Similarly, if customer also wants a whipped cream, we will call upon the Simple Coffee with milk decorated object and add additional cost to it and return that cost and that description, right? This way we can add any type of decorators that are optional. Okay. So this is the thinking behind the decorator pattern. Quite useful when you want to add additional things at runtime, right? So let's see all of this in code now. So I'm in VS Code now and we now have a decorator.cpp. Let's see the implementation. So first we have a Simple Coffee class, which is having the virtual methods get cost and get description, right? And this is being implemented by Simple Coffee class. And what does it do? It will implement the get cost and get description. So get cost will return $5. Get description will return the description basic coffee. Okay. And then we have the base decorator, right? How do we do the base decorator? Coffee decorator will also implement this one, the coffee interface, and it will have a constructor which will take in the coffee object, right? As you can see here, this is the coffee decorator constructor, and this is taking in a coffee object, right? And it is storing the coffee object in our protected space, right? And because it is implementing the coffee method, it will also have get cost and get description as implementations, and it is simply calling the get cost and get description of the coffee object that we already have, right? So we have the decorated coffee variable here and we are making use of it to get the base cost and base price, base description, right? So how do you use this decorator now? Let's say we are building the milk decorator, which is inheriting from the coffee decorator. And because this is inheritance, we already have access to the decorated coffee, whatever is the current state of the decorated coffee, right? So what happens now? Milk decorator exposes a constructor that will take in a coffee object. And this will also implement get cost and get description because it needs to override whatever was the current state of our coffee object, right? So in this overriding, what will it do? It will call upon the get cost from the decorated coffee protected object and add $2 to it. It will call upon the get description of the decorated coffee object and add milk to it, right? Similarly, if we have a caramel decorator, it will do the same thing, add 1.5 and add that string caramel, right? So in this way, we can build multiple decorators. Now let's see how to use this. So first, coffee making is simple. We create an instance of Simple Coffee, right? And if we do a cout, we will see that we will get Simple Coffee and $5 as the answer, right? And then we want to add milk to it. So what we do? We change the coffee object. We change the coffee object by passing the coffee object into the milk decorator, right? We create a new milk decorator instance by passing in the original coffee, right? So what do we get when we do get description from the decorated object? We get base coffee plus milk. we get the cost of base coffee plus milk, right? Similarly, if I want to add additional caramel, what will I do? I'm passing in the coffee object. Now this coffee is already decorated with milk, so that will have the description of coffee plus milk plus caramel, and it will also have the cost of coffee plus milk plus caramel, right? This way I'm able to alter the coffee object multiple times by passing it in through different decorators and adding additional responsibilities to it, right? So let's run this code and see. So as you can see here, first printout came as the description basic coffee with $5. Second description came as basic coffee comma milk $7. Third one came as basic coffee plus milk plus caramel at $8.5. So $5 plus $2 is 7, 7 plus 1.5 is 8, right? So when we are dealing with the caramel object, we were dealing with the milk decorated coffee object, which is having $7 as cost, and it is adding 1.5 to it. And we can repeat the process multiple times, right? So this is the whole idea behind decorator pattern, right? Now let's see some pros and cons. So far we have covered the intent, the example use cases, the UML diagrams, and also the code. Now let's see some pros and cons. The strengths of this pattern are quite obvious. It enables flexibility to add functionality at runtime. This is a great flexibility feature that we can do because we want to add additional functionality at runtime, right? We are not coupling it too much with classes and subclasses, right? And it also promotes open close principle because we can add any number of decorators as we want, and we are not enforcing anybody to use any decorator at any point of time. It's all optional. It also adheres to the single responsibility principle, as each decorator has its own responsibility, right? So that way we are addressing to the solid principles quite well here, right? And what about some weaknesses? Because we are dealing with additional classes and their own implementations as decorators, we have to increase the code complexity a little bit. So that is something to keep in mind. And then obviously there is a performance overhead because the object is getting passed down to other decorators and additional operations are being performed on it. So there is some performance overhead involved. So that is also something to keep in mind, right? But it's a great use case when you have to add functionality at runtime. You can see the implementation of decorators in many libraries and code bases, right? So those are some of the trade-offs of the decorator pattern, right? If you find any other trade-offs, definitely put them in the comment below. That's all for this video, guys. Thank you so much for watching. Don't forget to leave a like if you found this helpful. Do subscribe to the channel if you haven't done already. Do share it with your friends. Thank you so much for watching. I will see you in the next one. Cheers.